Hi guys. I have got 2 sick kids at home, and I am here trying to quickly do a lesson for you guys, so we'll see how fast I can get through this. I want you to remember that you can pause this video at any point so that you can catch up on notes, because I'm going to go kind of fast now. All right, here we go. So a binomial experiment is a probability experiment that satisfies these conditions. The first is that there are 2 possibilities. A success and a fail. And that doesn't mean that it's like a 50-50 success and a fail. They could have very different probabilities for each one. It could be a 30% chance success, 70% chance fail. But every trial that you have, there should just be, did they make it? Did they not make it? Whatever your conditions are. The second thing is that you've got a fixed number of trials in your experiment, so you know how many times you're going to run it. Next is that the probability of success stays the same for each trial. And finally, X, the variable, is the number of successful trials. So basically, it needs to be a yes-no kind of scenario. You need to know how many times you're going to do this experiment. Probability of success always stays the same. And you're questioning, like, what are the chances of me getting 3 successes out of 5? That kind of thing. As far as notation goes, N is the number of trials that you have. P is the probability of success. Q is the probability of failure. And X is the number of successes that you want, or that you're interested in. All right, so the first 2 questions is this a binomial experiment? So let's see, a certain surgical procedure has an 85% chance of success. So I'm going to write down right now. The chances of success are 85%. The chances of failure is 15%. A doctor performs the procedure on 8 patients. So N is 8. Random variable represents the number of successful, didn't finish writing, successful surgeries, I guess. My bad. I wrote these notes. Yes, this is binomial. We can identify the probability of success, the probability of failure. How many times they're going to do the trial doesn't change. Okay, next. A jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. That's a big deal. The random variable represents the number of red marbles. Okay, so X in this case is how many red marbles you get. You're randomly going to select 3, so we do have 3 trials that we're doing here. But the problem is that if you look at this, we've got 5 red marbles, 9 and 6. That adds up to what? 20. And then there's 5 out of 20 red marbles the first time. Okay, now let's suggest that you get a red marble. Then the next time it's going to change to 4 out of 19. Or maybe you didn't get a red marble, but that would still be 5 out of 19 because you did take a marble out and it says you're not replacing it. So the probability of success isn't remaining stable, so this is not a binomial experiment. So yes and no. Okay, your turn. You're going to try example 2 right now and see if you can do it. So pause the video and try it out and then see how you do. Okay, I'm assuming that you paused the video. Really hope you did. Take a multiple choice quiz that consists of 10 questions. Each question has 4 possible answers, only one of which is correct. Complete the quiz. You randomly guess the answer to each question. That's important because you need to not know what you're doing, otherwise your probability of success would change. The random variable represents the number of correct answers. Okay, so on this one, probability of success, there are 4 possible answers, one of which is correct. That's 1/4. Q, failure, is 3/4 or 0.25 and 0.75. N is 10 questions. And X is how many you're getting correct. Yes, this is binomial. Hope you got it right. Sorry I'm moving so fast. Got to get back to my kid. My daughter woke up this morning just with the worst tummy troubles ever and can't be far away from a bathroom. And Xander woke up and his stomach was also hurting, and he also had an eye crusted over, like pink eye, so we're just gonna see how that goes today. Okay, the binomial probability formula is n choose x times p to the x times q to the n minus x. Now, write it down, and then I'm gonna explain what this is. P to the x is your probability of success to the power of how many successes you want, which makes sense. Q is your probability of failure, which means that, so like let's say that you're doing 10 trials and you want 3 successes, then it would be your probability of success to the power of 3, and then your probability of failure to the power of 7, because you get 7 failures and 3 successes. That makes sense. And then this part, this n choose x, that is a combination that basically says which problems are you getting right. So it's choosing how many different choices there are for getting right. Like let's say you're getting 3 problems right out of 10. Well, it could be the first 3 problems, or it could be the last 3 problems, or it could be the first problem and the last 2, or the first problem and the 5th and the 8th. So this tells you how many choices there are for different possibilities of which ones you're getting right. When you're doing a binomial probability using your calculator, here's how you do it. Turn it on. Okay, you're gonna hit second and then this VARS button that says distribution in blue. You're gonna pick that one. And then you're gonna go down to binomial PDF. That is for one specific situation. A CDF is cumulative. PDF is for one specific probability. So it's a binomial probability or a binomial cumulative probability. So I'm going to click binomial CDF or PDF. If you have an old calculator, you have to put them in order, but this one you don't have to. So you just put in the trials, what your probability of success is. They don't ask the probability of failure because it can calculate the probability of failure based on the probability of success and what your X value is. And then you can do it from there, which we will do in just a second. So we're going to go down here. We're going to skip this part that says how to do it in the back of your book because I'm not doing that yet. And we're going to do this example. It says a card is selected from a standard deck and replaced. That's important. An experiment is repeated a total of 5 times. A success is selecting a club. Okay. When making your chart below, please fill in the probability that 0, 1, 2, 3. Hold on a second. Somebody's at my door.
During the school day, but I gotta be put back.
Okay, thanks for telling me. Hey Casey, I'm having to go home because I'm sick today, but I'm gonna see if I can come in and you guys can still paint. So I'll let you know, okay? Talk to Nathan, I'll text him.